Hello and welcome to CET 4884 Security Methods and Practice. In previous sessions, we addressed firewalls as one of the tools that is used in the planning for security to protect the company from external intruders. In this session, we will discuss in details firewalls technology, the various approaches to firewalls, and the implementation as security measures. As we stated before, technology can be used as a security tool on a method to protect, or as a method to protect the organization. In fact, technical controls are very important in enforcing the company's policy for many IT functions that have no control or no human control or automated. With the increasing amount of information and the need to have information available for use at the same time, the need to secure the information, a technical control will be the solution need to be used to balance availability and security. To understand the technical controls, we need to look at the different tools that can be used to secure information. First, we can start by controlling who can access the information and how, using what's called as access control. So the access control determine whether and how to admit user into a trusted area of the organization. Access controls could be mandatory, non-discretionary, and discretionary. The mandatory access control, or MAC, is a system control policy restricting access to resource objects such as data files, devices, systems, and other things, based on the level of authorization or clearance of the accessing entity, whether a person, process, or a device. In the discretionary access controls, a user has complete control over all programs and can determine the permission of other users on these programs. While non-discretionary access control is when the overall system administrator or a single management body within the organization tightly controls access to all resources for everybody on a network. To give the proper access, entities have to be identified. The identification process verifies the entity, the level of access, and the resources needed to be accessed. The entity that seeks a resource is called supplicant. Each entity will give a system identification or unique ID, which could be a single or could be a composite combination. In addition, it could include numbers and or special characters. Some organizations use a random generator to generate random numbers for these entities or for the IDs. Once a supplicant requests an access, the supplicant's ID will be validated to make sure of their claim. This process is called authentication. The supplicant might know information such as a password or a passphrase that only the user should know. So supplicant will be given access to other people's information because they can validate the account, which is not good. That's why it's important not to provide your password or passphrase to anyone and keep it in a safe place. Supplicant might have a smart card which contains a computer chip that can verify and validate the information for the user and then get access to the files that they should not access to. They could also have synchronous or synchronized tokens. The synchronous tokens is time synchronized to an authentication server for the purpose of creating one-time password. The token and the server clock, the two clocks must be synchronized to the same time base. The other token is called asynchronous, which is generate a one-time password the same as the synchronous, but don't use time synchronization between token and authentication server. It doesn't need that. Matching the authenticated entity to a list of information assets and providing them with the corresponding access level is called authorization. So you are authorizing that entity to access the information needed, or the directories of a certain type with certain authority. Authorization can be handled in one of three ways: authorization for each authenticated user, authorization for members of a group, so we can give the authorization for the group, and then anyone in the group will get the proper authorization to the directories and the files. And we have authorization across multiple systems. The authorized person will be accountable for the information he or she authorized to access. To identify the accountable person, we can review system logs, which records specific information related to that person or to the entity that did log into the system and to the directories with that authorization. And that's how we define, or we can identify accountable entities. To protect the system from untrusted entities, we can use a protection layer, or what's called a firewall. The firewall prevents specific types of information from moving between the outside world, known as the untrusted network, and the inside world, known as the trusted network. The firewall may be a separate computer system, maybe a software service running on an existing router or server, or a separate network containing a number of supporting devices. Firewalls can be categorized by the processing mode, the development era, and the intended structure. For processing modes, categorization include packet filtering, application gateways, circuit gateways, MAC layers, firewalls, and hybrids. Packet filtering firewalls examine the header information of data packets that come into or came into a network. The restrictions most commonly implemented are based on a combination of internet protocols, source of destination address, the direction inbound or outbound, transmission control protocols, the TCP, or user diagram protocols, UDP, source and destination port requests. Simple firewall models examine one aspect of the packet header, the destination and source address, or any of the other destination. They enforce address restrictions, rules designed to prohibit packets with certain addresses or partial addresses from passing through the device. They accomplish this through access controls, the access control lists that we talked about before, which are created and modified by the firewall administrators. There are three subsets of packet filtering firewalls: static filtering, dynamic filtering, or stateful inspection. For the static filtering, it requires that the filtering rule or rules governing how the firewall decides which packet or which packets are allowed and which are denied, and that will be developed and installed on the system. For the dynamic filtering, it allows the firewall to react to an emergent event and update or create rules to deal with the event. While static filtering firewalls allow entire sets of one type of packet to enter in response to authorized requests, the dynamic packet filtering firewall allows only a particular packet with a particular source, destination, and port address to enter through the firewall. Stateful inspection firewalls or stateful firewalls keep track of each network connection between internal and external systems using a state table which tracks the state and context of each packet in the conversation by recording which station sent that packet and when. Whereas simple packet filtering firewalls only allow or deny certain packets based on their address. A stateful firewall can block incoming packets that are not responses to internal requests. The primary disadvantage of this type of firewall is that additional processing required to manage and verify packets against that state table, which can leave the system vulnerable to a denial of service or a distributed denial of service attack. This table shows a sample firewall rule and format. We can see that we have the source address where the information are coming from, we have the destination address, and we have the type of service that we have, either HTTP, FTP, SMTP, and then if it's denied or allowed. The application gateway, application level firewall, or application firewall is frequently installed on a dedicated computer separate from the filtering router, but it is commonly used in conjunction with a filtering router. The application firewall is also known as a proxy server, since it runs special software that can act or that acts as a proxy for a service request. Since the proxy server is often placed in an unsecured area of the network or is placed in the DMZ area, it rather than the web server or the web services is exposed to the higher levels of risk from the less trusted network. So since it's in the DMZ, it's exposed more. It's the demilitarized zone, that area that doesn't have the protection. At that point, additional filtering routers can be implemented behind the proxy server, limiting access to the more secured internal system and thereby further protecting internal systems. The circuit gateway firewall operates at the transport layer. Connections are authorized based on addresses. It's like filtering firewalls. Circuit gateways firewalls don't usually look at data traffic flowing between one network and another, but they do prevent direct connections between one network and another. They accomplish this by creating tunnels connecting specific processes or systems on each side of the firewall, and then they allow one authorized or only authorized traffic, such as a specific type of TCP connection for only authorized user in these tunnels. The MAC layer firewalls, while not as well known or widely referenced as the firewall approaches above, the media access control or the MAC control or the MAC layer firewalls are designed to operate at the media access control layer of the Open System Interconnection OSI network model of communication. This gives these firewalls the ability to consider the specific host computer's identity in the filtering decisions. Using this approach, the MAC addresses of specific host computers are linked to ACL entries that identify the specific types of packets that can be sent to each host, and all other traffic is blocked. This figure shows firewalls types with the different OSI model layers. And we can see that we have the application, presentation, and session, and that's considered as application gateways firewall. And then we have the circuit gateway, which is in the transport, and the packet filtering within the network. And then we have the MAC layer firewall, which is in the data link layer. So far, we addressed packet filtering, application gateways, circuit gateways, and the MAC layer firewalls. The last one is the hybrid firewalls, which combine the elements of the other types of firewalls. That is the elements of packet filtering and proxy services, or packet filtering and circuit gateways. Alternately, a hybrid firewall system may actually consist of two separate firewall devices. Each is separate firewall system, but they are connected so they can work together to protect the overall network, the internal network. The first generation firewalls are static packet filtering firewalls, simple networking devices that filter packet according to their headers as the packets travel to and from the organization's networks. The second generation firewalls are application level firewalls or proxy servers, dedicated systems that are separate from the filtering routers and that provide intermediate services for requesters. The third generation firewalls are stateful inspection firewalls and monitor network connections between internal and external systems using state tables. The fourth generation firewalls are dynamic packet filtering firewalls and allow only a particular packet with a particular source, destination, and port address to enter. The fifth generation firewalls are kernel, proxy, and are specialized form that works under the Windows NT Executive or Windows kernel, which is the kernel of the current Windows or Windows NT. Firewalls can be also categorized by structure. Firewalls could be hardware or what's called appliances or software that can be configured on a device. Most of the firewalls are appliances, the standalone self-contained systems. There are commercial for large organization firewall systems. Some of them are small office or home office firewalls, appliances referred to as SOHO or SOHO, and residential grade firewall software. This figure shows a sample of SOHO firewall devices. And you can see that most of these are considered as appliances that can be configured or that can be installed on the network to protect the network and can be used for small businesses or home office. So which type of firewall should the residential user implement, software or hardware? Where would you rather defend against a hacker? With the software option, the hacker is inside your computer battling with a piece of software that may not have been correctly installed, configured, patched, upgraded, or designed. If the software happens to have a known vulnerability, the hacker could bypass that vulnerability and then have unrestricted access to your system. With the hardware device, even if the hacker manages to crash the firewall system, your computer and information are still safely behind the now disabled connection, which is assigned a non-routable IP address, making it virtually impossible to reach from the outside. So I think it will be a decision which one to use or to implement based on the results of the attack on the system. I will stop here, so that will be all for this session, and we will continue next time. So thank you and have a great day.